Okay, so today we're going to learn how to calculate something called molar mass. We're starting our unit on the mole, and we're going to learn what a mole is. We're going to learn what a mole is next class, but today let's just talk how to calculate molar mass, okay? So you have a few notes you're going to copy here. So way back in Unit 2, we learned how to calculate average atomic mass, where we took the weighted average of all of the naturally occurring isotopes of an element, right? If you don't remember how to do that, you might want to review it before you take your SOL in May, because that's going to come back. Originally, when we calculated average atomic mass, we said that our unit for the average atomic mass was AMU. What does AMU stand for? Atomic mass unit. From now on, we're going to be substituting grams per mole. That's what that G/MOL is. We're going to learn why we can do that substitution next class. Okay. All right, so the steps for calculating molar mass. The first thing you need to do is write the chemical formula. Sometimes, the examples that we're going to have, I'm just giving you the formula already. The other examples, you might have the name and you have to write the formula. Remember, nothing ever goes away in chemistry, so the names, writing the formulas from the names, that Unit 4 stuff, ain't going away. All right? So you're going to write the chemical formula. Then you're going to calculate the molar mass by adding up the masses of each element in the compound. If there's more than one of a particular element, you're going to multiply its mass by how many you have before you add. And then again, the units are grams per mole, G/MOL. Are we ready to go to the next page? All right, so on the next page below your chart, below the chart that we're going to be filling in, fill this in and then we're going to go back to the chart. I wanted to get this in first before we do some examples. So molar mass is the big umbrella term. We have three particular terms depending upon the type of substance you're calculating the molar mass of. For example, formula mass is the molar mass of an ionic compound. Atomic mass is the molar mass of an individual element. And then molecular mass is the molar mass of a covalent compound. These are just different names for different types of particles, but they're same method of determination. It's all molar mass. It's like I can say I'm a chemist, or I can say I'm a science teacher. That's the broad general term for what I do. But I can be more specific and say I'm a chemistry teacher. Okay? All right, are there any questions so far? All right, are we done writing? We good? Okay. So let's go back to the chart that's on the previous page for you guys. Do you have your calculators ready and your periodic tables ready? Because you're going to need them. All right. So our first example, number 1. K, which is what element? Potassium. What type of particle is that? It's an element. So does that mean that we are calculating FM, AM, or MM? AM, because we're calculating the atomic mass of an individual element. Who do you need?
Do you have anybody from the
National Science Honor Society? You might want to check next door because that's ISR. And there's a bunch of them. And that's on camera right now. Or we can grab one of the ISR people. I mean, if you want to go, that's fine. Fine, you can go if you want. I don't know. All right. So we're going to go to the periodic table. We're going to find the mass of potassium, right? What is the mass of potassium on the periodic table? $39.0983. Now, one thing I meant to say back here, don't worry, I'll come back to that. When we calculate molar mass, when we pull a number from the periodic table, we are going to round our answers or round our numbers to 2 decimal places. Okay, make it nice and easy. All of our numbers we're going to round to 2 decimal places. Okay? Okay. So 39.0983, what is that rounded to 2 decimal places? 1, 0. And what are my units? Grams per mole. Not AMU, it's now grams per mole. And again, we'll learn how we can do that relationship between AMU and grams per mole, why we can make that substitution next class. All right, so the next one, KCl. What type of particle is KCl? It's an ionic compound. So are we calculating FM, AM, or MM? FM, formula mass, because it's for an ionic compound. All right, so let's calculate it. So this one we actually have to do a little bit of math here. We just pulled potassium's molar mass from the periodic table in the previous one, 39.10. And then we're going to add that to chlorine's mass. Remember, when you pull it from the periodic table, round it to 2 decimal places. What is chlorine's mass rounded to 2 decimal places? $35.45. So add those 2 numbers up and then make the unit what? Grams per mole. Point what? 74.55 grams per mole. Good. Okay. Easy peasy. All right, the next one, SO2. What type of particle? Covalent compound. So what are we calculating? molecular mass. Again, all of these are molar mass. Molar mass is the general term. Formula, atomic, and molecular are just the more specific terms. All right, so we have sulfur and oxygen, right? And we have 2 oxygens. 1 sulfur, 2 oxygens. What is the mass of sulfur rounded to 2 decimal places? 32.06. Some periodic tables, if you're not using the one I gave you, might say 32.07. That's okay. 32.06 plus, we have 2 oxygens. So we're going to multiply oxygen's mass by 2 before we add it to sulfur's mass. So oxygen on the periodic table has a mass of what? Well, it's like 15.9994, which rounds to 16.00. Remember your rounding rules. I've seen some weird things happen with rounding where people write that as 15.10. It all gets pushed up. Okay. All right, so go ahead and calculate that. What did you get, Brian? 64.06 Grams per mole. Now, I'm going to let you guys do the calculations for the other two, but I want to set it up for you guys, or at least for the first one. What types of particles are 4 and 5? I'll give you a hint. They're the same type of particle. They're both ionic compounds because they contain ions. We have calcium phosphate and sodium carbonate. Or, sorry, not sodium, ammonium carbonate. They're both ionic compounds. So therefore, what are we calculating for both of them? Formula mass. Now, let me set up this first one for you. Bless you. How many calciums are in calcium phosphate? You can see the subscripts better on your page. How many calciums are there? 3. We have 3 calciums. How many phosphoruses are there? 2. The 2 outside the parentheses distributes to everything inside. So we have 2 phosphoruses. And how many oxygens? 8. 2 times 4 is 8. 8 oxygens. So when you do that, you're going to take calcium's mass times 3, phosphorus's mass times 2, and oxygen's mass times 1, and add them all up. All right, so by now you have calculated the molar mass for 4 and 5. So what did you get? So when we did 4, what's the mass for calcium? 40.08. 2 decimal places. So calcium's 40.08. What's phosphorus? 30.97 plus 8 times, what's oxygen? 16.00. All right, so when you add those all up, multiply and add, what do you get? Whoa, I'm hearing. 310.18? Okay. But 310.18? Okay. And what's our unit? Unit 2. You use AMU when you're calculating average atomic mass, which we've already gone over back in Unit 2. All right, and then for number 5, we have how many nitrogens? 2. And nitrogen has what mass? 14.01. And then we have how many hydrogens? 8, which has a mass of 1.01. And how many carbons? Which has a mass of 12.01. And 3 oxygens that have a mass of 16.00. When you add all of those up, what do you get?
6.11.
There we go. Units? All right. So that is calculating molar mass. We're going to use that next class to do a few more things with it. Okay?